in this problem, we are told that a sample of 10 students took a class designed to improve their SAT math scores. Now, whenever you have a situation where there is an original value and then a value that comes after that, we're looking at a matched pairs situation. So I wrote matched pairs up here. They don't specifically say that in the problem. However, if this were a situation where we were doing a two-sample t-test, you'd have two separate sets of data rather than two sets of data that are paired up in this fashion. So when you see these data values paired up, it's a matched pair problem. Now, in your book, they give you more of a hint because it says right here, mu sub d equals mu1 minus mu2. And so that's going to tell us how to enter the data into the calculator. So I'll start off by putting my before data into L1 and my after data into L2. Now, because we need to find mu sub d, we're going to find, or I should say, we're going to find L3 by letting L3 be L1 minus L2. And we're going to put that in the very top. I'll show you where when we get to the calculator screen in a second. Okay, so first we state the appropriate null and alternate hypotheses. So right here, we can see that the null hypothesis is that mu sub d is equal to 15 because the null hypothesis is always an equal to statement. And the alternate hypothesis is not equals because it just says, does it differ from 15 points? Not, is it greater than 15 points or is it less than 15 points? So, okay, now we're looking at the calculator screen. So let's focus on this first screen here where I entered the data. So I put my data into list 1 and list 2. And then list 3, I created this list by moving the cursor. Here it's in the first line of data. I want to move that cursor into the very tippy top right here where it says L3. And when it says L3, then what I'm going to do is I'm going to type in L1 minus L2. And I do that by pressing second and the number 1, subtraction sign, not the minus in parentheses, but the regular subtraction sign, and then second and the number 2. And that'll give me L1 minus L2 here. I press enter, and all the values fill in automatically here. That's the hardest part of this whole thing, is just getting all that data typed in and then getting L3 set up. So now we've got our matched pairs in the data, but we also found the differences. So the question is the difference between these two lists, on average, is it different from 15 points? So maybe it's less than, or maybe it's greater than. So that's what we're looking to find out here from this list of data. So we're going to do a t-test. Whenever it's matched pairs, we do just a regular t-test like we did in Chapter 9. My input is data. The difference usually is 0 in these problems. Almost every single time, except your book does this one like weird question out of all the homework where it's 15. So in this case it's 15. And then the list is L3. We don't care about L1 and L2 anymore. They've been incorporated into one list here. So, and the frequency is 1. We're going to skip over that, just move on past there. The alternate hypothesis is a not equal to. This is a two-tailed test, so I make sure that that's selected. And then I can choose either calculate or draw. And I gave you both options down here. So if you choose calculate, you get this screen. If you choose draw, you get this screen. I personally like draw because really all I want out of here is the test statistic, T, and the p-value. And actually the homework, they don't ask you for the test statistic, they just ask you for the p-value. So that's the p-value that I have here. And you can see if you choose calculate, you've got this p-value, which is in scientific notation, annoying. That's why I like the draw screen. If you get an error here, then you want to go into y equals and make sure that all your plots are turned off and that you don't have any functions that are trying to be graphed there. So, so that's what goes on. Sometimes people have trouble getting the draw screen to come up, but I really do like that because who wants to round off that p-value if you don't have to? But if you do choose calculate, you see the p-value. It is, oops, let's see. So we've got 0.0000495, and I don't really need all of this, right? Because our p-value we're going to round to 4 places, and so the 4 doesn't round up the 0, so we just call it 0. So 0 is my p-value, and that means that we are going to reject the null hypothesis, and because we can see that that p-value is significantly different from 15, I'm sorry, not the p-value, that our mean is significantly different from 15. Our p-value is very small, so it's a value way out here. And so that is the end of that problem.